Hi, scholars! We're back! It's Miss Janice and Trixie here to talk to you some more about adaptations. Yes! And we are going to jump right into it. All right. Today is Tuesday, April 21st. Tomorrow is Wednesday, April 22nd. It's Miss Janice's 26th birthday. But in other news, I miss you guys so much, but also I hope that you are staying healthy, safe, and calm. Today is all about adaptations. But before we jump into types of adaptations and what causes species to adapt, let's review. Last week, we talked about traits, adaptations, and natural selection. Traits are characteristics of organisms that are passed from parent to offspring. So think color, size, shape. We can see a trait of this cute little fox guy is his big old ears, and a trait of this cool, funky little plant is his spiral leaves. Organisms and a population of species have varying traits, like these different bunnies, meaning they don't all look the same. If an organism has a trait that helps it survive and thrive in its environment, it is an adaptation. An adaptation is a trait that helps an organism to survive in its environment that results from natural selection. Remember, organisms cannot change their traits on their own. They are either born with the trait or not. Remember last week we looked at different finches that had different looking beaks. And we know that these beaks are adapted traits that resulted due to competition for food resources. So this bird we can see has a very strong beak that he can use to eat seeds, while this bird has a thin beak where he can reach into crevices to get different insects. So organisms born with the adaptation will survive to pass it on to their offspring. Organisms born without the adaptation will not survive. This is known as natural selection. Let's look at our funny little example with our giraffes again. We can see that the advantageous trait is having a long neck to reach the food source. Giraffes without a long neck will not be able to eat to survive and will die off. The good thing for the species is that the long-necked giraffes will produce long-necked babies. The species will continue to eat to survive. This is natural selection. Today, let's talk about our objectives. Scientists, you will be able to differentiate between types of adaptations in species and identify and explain what factors can cause adaptations in species. Let's start with the types of adaptations. There are 3 types of adaptations. 2 of these types are considered biological. So a biological adaptation is a physical or physiological change in an organism that results over time in reaction to its environment. Don't let those words intimidate you. Think of them this way. A physical adaptation is an adaptation that you can see. For example, this hedgehog has has spiky quills to protect him. I have no idea if they're spicy. I have never eaten a hedgehog quill. But this is a physical adaptation. Oh my gosh, I cannot speak today, y'all. Physiological adaptations. Physiological adaptations are adaptations that you cannot see. For example, the black walnut tree. This black walnut tree has an adaptation in which it produces a toxic chemical in order to compete with surrounding plants for space to grow. You can't see the plant's insides creating or secreting this chemical, but it is a trait that helps the black walnut tree to survive and thrive in its environment. Therefore, it's a physiological adaptation. Adaptations can also be behavioral. Behavioral adaptations are the way an organism acts or what it does in order to survive and thrive in its environment. For example, birds migrating south to avoid cold winters is a behavioral adaptation. They know that they will not be able to survive the winters in their environment, so they migrate south to have a warmer winter. All right, let's take a look at the physical, physiological, and behavioral adaptations of emperor penguins. Last week, I was all about moths. Today, it's emperor penguins. All right. Their physical adaptation, they have a short, stiff tail to lean back on. So this prevents heat loss through their feet by reducing contact with the ice. So here are some cute examples of penguins leaning back on their strong tails. A physiological adaptation that emperor penguins have is their heat exchange systems. So these systems keep their flippers and legs cooler than their core to prevent disproportionate heat loss. Why do these penguins need to prevent heat loss so much? They live in the deep south, y'all. I'm talking Antarctica. They live in the coldest, windiest continent and endure some of the most extreme conditions. Their average winter temperature is negative 56 degrees. So how have they adapted to this cold, windy, extreme environment behaviorally? Well, they huddle together to conserve heat. Not only that, but they take turns being on the outside of their huddle in order to shield each other from the wind. They also make sure that they don't touch each other so that they can get maximum insulation from their own feathers as well as from their friends. That's a 3-in-1 behavioral adaptation. Yes! And okay. We know that natural selection is the passing of advantageous traits from parent to offspring. The species with the tools to survive will survive to pass them on. RIP to the organisms that don't have the adaptations. So, what causes species to adapt? Our world is continually changing, so animals and plants need to have various ways to adapt to those changes through natural selection. Remember our peppered moths? I bet you do. The advantageous trait changed from being white in color to being black in color because their environment changed. So what are these changes? Well, they can be abiotic, like changes in temperature. One way species can adapt to changes in temperature, maybe an increase in temperature, is staying underground and burrowing underground during the day, like the great bilby. He's also nocturnal, meaning he does all of his business at night, so he doesn't have to deal with the heat. You can also see a change in the amount of sunlight. This Mediterranean plant endures a lot of sun. The hairs on the surface of this Mediterranean plant are used to reflect sunlight from their surface and reduce the movement on air on their surface, which leads to less loss of water. Another abiotic example would be a change in the amount of water. The leaves of forest trees have adapted to cope with exceptionally high rainfall. So many tropical rainforest leaves have a drip tip. These drip tips enable raindrops to run off quickly, and plants need this to shed off water so they avoid the growth of fungus and bacteria in the warm, wet, and tropical rainforest. So this drip tip is an adaptation for not only the amount of water, but also the warm temperature of the rainforest. These factors can also be biotic, like the presence of competition. In the rainforest, there's a lot of competition for sun. So the strangler fig competes for sunlight by sprouting on top of trees and dropping its roots all the way down to the ground. Predators can also be a biotic factor. We've already seen prey adapting to predators by being camouflaged, but here we can see a caterpillar mimicking the look of a snake to scare predators. So predators can also be camouflaged so that they can easier sneak up on prey. So this snake is going to have a really easy time sneaking up on prey due to his advantageous trait of being camouflaged. He's the same color as his surroundings. So short-term and long-term environmental changes can also cause species to adapt. So short-term environmental changes are things like floods, fires, and oil spills. And these changes happen quickly and allow little time for organisms to adapt biologically. So these organisms will either die due to the change or they will have to move. So we can see an example of this koala here. It seems like his environment is suffering from a flood. He's probably not going to have koala babies in the next 2 weeks that are going to have fins. That's just not enough time for him to adapt biologically. So unfortunately, he will probably have to move or die due to this change. So long-term environmental changes can also cause a species to adapt. These are changes like pollution and climate change, leading to changes in precipitation and higher temperatures. These changes occur slowly over time and can permanently change an ecosystem. Some traits may become more or less advantageous. If biological adaptations to the change are present, organisms will survive to reproduce. We've seen this already with our peppered moths during the Industrial Revolution. Another example is the pika, which is very sensitive to temperature. It has behaviorally adapted to increasing temperatures by migrating to areas of higher altitude. So it's really sensitive to heat. So due to increasing temperatures, it's having to migrate to areas of higher altitudes or areas with lower temperatures. All right, y'all, now that we are experts in types of adaptations and what factors can cause a species to adapt, we are going to jump into our independent practice. So when I say go, you will jump to the Google Classroom post for today and open the link titled Organisms and Environmental Change. You will complete the interactive and answer all of the questions in your classwork. There are 11. And then you will turn it in Google Classroom. I hope that you all enjoyed your lesson for today on adaptations. If y'all have any questions, please feel free to email me or Miss E. We are here to help y'all. Y'all have a wonderful day and take care. Bye. Wait, yes.